Hello everyone. Welcome to PW. Good evening everyone. Please let me know by writing in the comment section whether audio and video everything is perfect or not. Please let me know by writing in the comment section beta ji whether audio and video everything is perfect or not. Great. So audio video perfect. Please let me know by writing in the comment section beta ji whether audio video everything is perfect or not. Hi. So now we are on lecture number 8 and this is the last lecture of your combinational circuit. Okay. After this lecture we will move towards sequential circuit, a small portion of combinational circuit in which we need to have questions based on the memory. Okay. Like how to use the EROM or double EROM, that we have to study. Okay. But that we will go with the last lecture. Overall, whatever described in your syllabus, especially in CS, EC, EE, IN, already I have covered. So how many of you able to understand up to this part, beta ji? Great. So today I am going to discuss the last part, but this last part is very important as well because we are going to learn about the BCD to decimal decoder. Okay. And in the form of BCD to 7 segment decoder. Later on we will see encoder and priority encoder. Priority encoder is very important, especially for gate. Okay, for both, for all the branches. Actually, priority encoder is important for all the branches. So everything is perfect. Great. When machine will start, it will take time, beta ji. Okay. So let us first discuss about the topic covers today. Today I am going to cover first part, decoder part 2, where we will see BCD to 7 segment decoders, and later on we will move towards encoders, in which we will see normal encoders and priority encoders. So please write down first BCD to 7 segment decoder. Please write down BCD to 7 segment decoder. Please write down BCD to 7 segment decoder first. Great. See, whatever we are observing in terms of numbers, like our watches, our calculator, so they are somehow connected with the same BCD to 7 segment decoder. Please observe, it is used in digital multimeters, digital watches, and a number display device and electronic calculators. How it would work? It is used to take a 4-bit BCD input that provides output that will pass current through appropriate segments to display the decimal digit. So to design any combinational circuit, we always follow 4 steps. First step is to identify the inputs and outputs. Next step is to construct truth table. Then write logical expression and minimize it, and then implement the logic circuit. So again, these 4 steps are going to be taken care of in this BCD to 7 segment decoder as well. So first of all, we need to understand the input outputs and their relationship. Please observe, we have to design a BCD to 7 segment decoder. Here we have one decoder, BCD to binary coded decimal to 7 segment. Binary coded decimal is from 0 to 9. Binary coded decimal is from 0 to 9. Yes, sir. So for 4-bit BCD, we need 4 input pin that I am describing as A, B, C, D. Is it okay? Yes, sir. Capital A, B, C, D as I3, I2, I1, I0 pin onto the BCD to 7 segment decoder. BCD to 7 segment decoder. And we have 7 segments. you can understand like we have these 7 segments. Okay, please observe. One, two, three, 4, 5, 6, and 7. So we have 7 segments. Is it okay? You can indicate it as segment A, segment B, segment C, D, E, F, G. So I am indicating the segments here as segment A, B, C, D, E, F, and G. Now we have to design a BCD to 7 segment decoder, and we have a 7 output pins which are connected with the appropriate segments, like output pin A is connected with the segment A, output pin B is connected with the segment B, and so on. A, B, C, D, E, F. You need one more. Okay. So A, B, C, D, E, F, G. How many of you able to understand up to this part? What we want? Sir, actually you want to design a digital circuit. You want to design a digital circuit to display a decimal digit. If we are able to display a decimal digit, we are able to write ABCD as well with a more number of segments. If we are able to write ABCD, then we can display your face also, sir. We can design TV also, sir, or any display unit, sir. Yes. How many of you able to understand? Great. Even we can able to design the LED TV, sir. The logic circuit required for the LED TVs, where the same LED will emit different colors of light to display, and the combination of LEDs can make a LED TV as well. Yes, sir. Okay. Great. So if we talk about Betaji, I am presently discussing about this, so please be on this only. Okay. Now please see. So we have to design a 4-bit. It takes 4-bit BCD and provides 7 segment outputs. And how the 7 segments are connected? So they are basically connected. The output of the decoders are connected with this. We are not interested how this will work. I am only interested how the BCD to 7 segment decoder is going to operate. Is it okay? Yes, sir. Now please observe. If you want to design such a circuit, it means if we are giving the input as say 0, 1, 0, 1. So this is the binary coded decimal of 5. If we are going to apply 5 on the input of BCD, then appropriate segments will become high and it would display 5. So how it would display 5? When B is in off state and E is in off state, then it displays 5. So what does it mean? It means we want to design a digital circuit. If the input is appearing as the input of binary of 5, then appropriate output pins will become high, that will pass current through the appropriate segment. So it means A need to be high, B need to be low, C need to be high, D need to be high, E need to be low, F need to be high, G need to be high. How many of you able to understand? So it can display 5. In the same way, you know how to display 3. How many of you able to understand, beta ji? Can you please tell me how many of you able to understand? Great. How many of you able to understand up to this part? Please let me know by writing in the comment section. Great, sir. So, to design any combinational circuit, we are interested to design the digital circuit used in this decoder. To design any combinational circuit, first of all, we need to identify the input, output, and their relationship. So, would you now know about the input, output, and their relationship? Yes, sir. Whatever binary coded decimal we are going to apply, then according to that particular number, those output pins will become high. So now you know about the input and output relationship. Next is to construct truth table. So let's move to the truth table. Let's move to the truth table. How to construct truth table? Please observe, beta ji. How to construct truth table? So now next is to construct truth table. We have an input A, B, C, D, and output we have a small a, B, C, D. Please observe, beta ji. Making it little bit bigger. Okay. So A, B, C, D. This is the BCD input. We have output A, B, C, D, E, F, and G. Is it okay? Sir, we may get the 0, 0, 0 as the input to the decoder. 0, 0, 0, 1. BCD is from 0 to 9. Yes, sir. 3, 4, 5, 6, 7, 8, 9. Now, can you please tell me what are the particular combinations? Hoping all of you now able to understand with what topics we have completed. Till date now, you will now be able to understand how to design any desired combinational circuit. So this is a practical example of designing a desired combinational circuit. First of all, identify the input, output, and their relationship. Next, construct truth table accordingly, and then write logical expressions of the output and implement the logic circuit. How many of you now able to understand, beta ji? Great. So now please observe here. In this, we want for 0, what we want? For 0, we want 0 get displayed. In case if the input 0, 0, 0 would appear to the input of decoder, then to display 0, A, B, C, D, E, F need to be high, only G need to be low. So if G is low, you can represent like this, all are high except G to display 0. In the same way, to display 1, sir, these needs to be low. We have one G as well. So only B and C if high, then it can display 1. So only B and C are high, rest all are low. Is it okay? Then they will pass B and C segment. High current will be passed through B and C segment, and B and C segment get glow. Is it okay, beta ji? Great, sir. Now, can you please observe what is going to be high for 2? Here we have a binary of 0, 1, 2, 3, 4, 5, 6, 7, 8, and okay, this I have repeated. So leave this space because it got repeated. Allow me to change this. Okay. You can just cut that, but let me allow to change this. 0, 0, 0, 0, 1, 1. Binary of 3. Binary of 3. Then binary of 4. Binary of 5. Binary of 6. Binary of 7. Binary of 8. And binary of 9. Okay. I made 3 twice, so kindly correct it. This is your binary of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it okay? Yes, sir. Now for 2, how to represent 2? All of you know how to represent 2. For 2, F and C need to be low. So F and C need to be low. F and C need to be low. Rest all are high. How many of you able to understand? Yes, sir. Great. For 3, to display 3, we need to make A, B. To display 3, only F and E need to be low. Rest all are high. To display 4, segment. Betaji, all of you able to understand this? Please let me know by writing in the comment section. To display 4, F, E, F, G, B, C need to be high. Okay. And E, D and A need to be low. E, D and A need to be low. So sir, to display 4, if we are representing 4 like this, to display 4, we have A low, B high, C high, D low, E low, F high, G high. To display 5, sir, to display 5, only B and E need to be low. B and E need to be low. Rest all are high. How many of you able to understand up to this part, Betaji? Please let me know by writing in the comment section. Is it okay now? Great. To display, sir, A, D, E is low. Very good. Yes, Saroj. A, D, E is low for 4. A, D, E is low for 4. For 5, we have B and E. Can you write 6? So if you have observed 6, it will be represented like this. But in order to have same logical expression as that given in your most of the reference textbook, we have to consider this as a display of 6. We can use either that, or we can use in this way as well. This is a display of 6 only. So for this, you can say, sir, A and B are low. A and B are low. Rest all are high. To display 7, sir, A, B, C need to be high. A, B, C need to be high. A, B, C need to be high. Rest all are low. To display 8, 8 is a special one in which all the outputs will become high. So for 8, all will become high. and to display 9, output A, B, C, G, F are high, D and E are low. How many of you able to understand up to this part? Please let me know by writing in the comment section, beta ji. Yes, for 8 all are high. Great. So how many of you now able to understand what I want to design? I want to design a desired combinational circuit here. And how to design a desired combinational circuit? To design any desired combinational circuit, we can design inside the chipset, whatever required inside the logic gates required in this. We can design by simple 4 steps to identify the input-output relationship, construct truth table, write logical expression, and implement the logic circuit. The first and most important is to identify the input-output and their relationship. So now we know about 4 input and 7 output, and the relationship also that in order to display a decimal digit, appropriate number of outputs or appropriate outputs are to be high. How many of you now able to understand up to this part? Please let me know. Great. Sir. There is no restriction of class 12th marks, beta ji. For gate, there is no restriction of class 12th marks. Okay. Only gate score is important for you. Now, please observe. First of all, we need to construct. First of all, now we know about the relations between input and output. We have all the outputs. Can we find out the logical expression for A, B, C, D, E, F, G? Yes, sir. So, how to find the logical expression for A? Please observe. How to find the logical expression for A? A is high onto the binary combinations of, if you observe A is high onto the binary of 0, 2, 3, 5, 7, 8, 9. So only 4 and 1, 2, 4, 1 and 6, 3 places where it is 0. So 1, 2, 3, 5, 6, 7, 8. 1, 2, 3, 5, 6, 7, 8. 1, 2, 3, 5, 6, 7, 8. And what about rest? Because we are only considering up to 9. What about more than 9? Because for 4 input pins, the total number of possibility is 15. Because we are giving BCD. BCD is only from 0 to 9. It means from 000 to 1001. Is it okay? So what about the binary condition of 10? It would never going to be appear because we are applying BCD. So those conditions which are never going to be appear at the input, for that we will consider output to be don't care. So it means we have don't care 10, 11, 9 is also high, na? 9 is also high. 8, 9, 10, 11, 12, 13, 14 and 15. So can we go with the K map? Yes, sir. For finding the minimized logical expression required for output function A, we can go with a K map. This K map will give you, sir, we have AB as per the MSB, LSB 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So we are getting binary of 0, 1, binary of 0, binary of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. What are the positions where we are getting output logic 1? 1, 2, 3, 5, 7. 6 is low, na? 6 is low. 6 is low. 5, 7. 6 is low, beta ji. 6 is low. 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 6 1 is also low. 0 hai. 0. We have 0. Sorry for this again. We are having 1, 2, 3. 0, 2, 3. 0, 2, 3. 0. We are getting 0. 0, 2, 3, 5, 7, 8, 9. It is very near to me and quite difficult to view without glasses. So please observe here. 0, then we have 2, 3, 5, 6, 7, 7, 8, 9. Is it okay? Yes, sir. So 0, 2, 3, 5, 7, 8, 9. 0, 2, 3, 5, 7, 8, 9. And then rest all are don't care. So is there any possibility of octet? Yes, sir. What is the possibility of octet? We have one possibility of the corner octets. Can we take this octet? Yes, sir. We have one more possibility of octet, sir. This one. And we have one more possibility of octet, sir. 6 is not there. 6 is not there. We can't have this octet. 6 is not there, na? 5, 7. Only one octet we have, this octet. And but instead of having this octet first, let us first observe the other things because it requires most of the don't cares. So we have one chord, we have one chord, we have one more chord. For this one, we can go either with this, it will cover more. So we have this chord. Now, in order to cover this, we need to go with the one octet. We need to go with one octet as well. So the logical expression for a function A will become, sir, this is your A bar, B bar, A bar, B, A, B, A, B bar. How many of you able to understand, beta ji? C bar, D bar, C bar, D, C, D, C, D bar. Kindly do the correction, beta ji. Kindly do the correction. 0 is also high, sir. I have taken here 0, 2, 3, 5, 7, 8, 9. 0, 2, 3, 0, 2, 3, 5, 7, 8, 9. Now everything is correct. I did all the correction. Is it okay now? Great. So we have A, we have octet. From octet we have A, but instead of considering octet first, let's take other thing first, okay? And that I will let you know why I haven't taken the octet first. Now please observe the corner ones. The corner ones, if we consider the corner ones, then we have B bar and D bar. So we are getting B bar, D bar plus of. If you observe the center chord, then we have B, D. So we are getting BD plus of. For this, we are getting CD, which can be created in another way as well, like this. But there is no issue. You can use there. We all know that multiple solution of the multiple minimized expression is possible from a K map, okay? But it always gives the minimized expression only. So you can take one. Now please observe. The last one is A. How many of you able to understand? Instead of going with this, whenever you are minimizing the function with the BCD functions, whenever you are having an input BCD function, then one thing is clear that from 10 to 15, always it is don't care. So whenever we have a BCD input function, we all know that one thing is clear, from 10 to 15, there is always a don't care. Is it okay? So only the condition of 8 and 9 will come. So for BCD only, we can opt another way to do the minimization of the logical function. Now please observe here. I am using one alternative approach to minimize the same function. Please observe here. Alternative approach. So if you use alternative approach, then please observe we are getting high. A high onto the condition of 0, 0, 2, 3, 5, 7 and 8, 9. I am considering this 8, 9 apart. Why? Because only we have to check the condition of 8 and 9. We all know this is only valid for the BCD, only for BCD, only for BCD, binary coded decimal inputs. Okay, so if we have a binary coded decimal inputs, then we can use BCD only. Out of A, B, C, D, 4, I'm using only B, C, D, 3 inputs. So for 3 inputs, we have a K map BCD. For BCD input, we can construct a K map B bar B, C bar D bar, C bar D, C D, C D bar. Now please observe 0, 1, 2, 3, 4, 5, 6 and 7. Where we are getting output logic high, beta G? We are getting output logic high on 0, 3, 2, 5, 6 and 7. So please observe, first we have A is equals to, how many of you can observe this now? Please observe, beta Ji. We don't have 6 now. There is no 6. Okay. So from this we have one possibility. Either we can go with this or we can go with this. So in this also, either we can go like this or we can go like this. So two possibility. Here I am considering the same CD. This one can be paired with this only and this one can be paired with this only. Is it okay? So we have this one as B bar D and this one as BD and this one as CD. Now we have to check whether the function is capable to define 8 or 9 or not. If the function is capable to define 8 and 9, then need not to consider the octet, because we all know that from 10 to 15 we have don't care. So only we are interested to know whether this octet is needed or not in case if 8 and 9 is included. Is it okay? Only we have to check whether that octet is needed or not. If this expression is sufficient to define the pin A, then we need not to add A, we need not to take this octet. In case if this expression is not sufficient to define 8 and 9, then we need to take that octet, because for 8 and 9 we want high. What is the binary for 8? What is the binary for 8? We know 8 is 1, 0, 0, 0. So if we talk about 9, we have 1, 0, 0, 1. So this is your capital A, capital B, capital C, capital D. Let's observe whether the function is capable to define 8 or 9 or not. If we are going to observe this, D is a 0 for 8. Yes, sir. So 0. D is a 0, 0. D is a 0. It means 0. So for 8, we are getting 0, but we want 1. So this expression is not sufficient to define 8 and 9. We need to add A in this expression. Is it okay? It means that octet is needed because the expression is not sufficient to define 8 and 9. How many of you able to understand? So it means this octet will now needed. This is a shortcut for BCD. It is only valid for the binary coded decimal. So can I use the same? Can I use the same for expression of B, C, D, E, F, G? Yes, sir. Let's try to have an expression in order to understand this concept as well. So B, can you tell me what are the positions where B is high? Where B is high? Can you tell me what are the positions where B is high? Now I am only using B, C, D, B bar, B, C bar, D bar, C bar, D, C, D, C, D bar. Okay. In the same way, 0, 1, 2, 3, 4, 5, 6 and 7. So B, C, D, E. Let's observe the expressions of B, C, D, E. Okay. Can you please tell me what are the positions where we are getting B high? We are getting B high. We are getting B low only on two positions, that is 5 and 6. Only 5 and 6 B is low. B is low only at 5 and 6. Rest everywhere it is high. So 0, 1, 2, 3, 4, 5 and 6, 7, 8 and 9. Now if you observe, we have 0, 1, 2, 3, 4, 7. Okay, so the logical expression for B, the logical expression for B is, the logical expression for B is, the logical expression for B is, we all can see we have B bar needed plus of C bar D bar plus of CD. Whether this expression is sufficient to define 8 and 9, for that you can check B. What is 8? 8 will have the binary 1, 0, 0, 0 and 9 will have the binary 1, 0, 0, 1. So here we have A, B, C, D. We are getting B is 0. If B is 0, it means what? We are getting B bar 1. So this is a sufficient to define 8 and 9. In this case, that octet will become redundant one. It is not needed because that octet will only be considered by considering the don't care as logic 1. Is it okay? This octet I am talking about. So now this octet is not needed. And why it is not needed? Because this 9 is already being coded with the above 0 and 1. How many of you now able to understand? Great, sir. In the same way, if we talk about C, for C we are getting only 1 0. So that is 2. Except 2 all are high. Except 2 all are high. So 0, 1, 3, 4, 5, 6, 7, 8 and 9. For BCD only I am using 8 and 9. Check separately. So we have 0, 1, 3, 4, 5, 7, 6. Only 2 it is low. So we have 1. This is B, not B bar. I have copied everywhere. So the same error is being copied everywhere. This is B, beta ji. Yes. So we have a B bar. Please observe, beta ji. This is B. One we have B, another we have C bar, another we have D. Okay. So the logical expression for C will become B plus C bar plus D. This expression is again sufficient to define 8 and 9. Need not to add A in the MSB, because for C0 and for C0 in 8 and 9 we are getting C bar high. So for C we are getting logic level 1 only. This is a small c and here we have a capital C. Okay. Great. Now please observe for D. For D we are getting high where? Sir, we are getting high onto the binary conditions except 1, 4, 1, 4, 7, 8. 1, 4, 7, 9. Except 1, 4, 7, 9. Here 8 is not. How it is possible? 8 is high everywhere, na? 9, it is low. It is low on 9. So D we have 1, 4, 7 and 9. 1, 4, 7, 9 we are getting low. 1, 4, 7, 9 we are getting low. So except 1, 4, 7, that is the binary of 0, 2, 3, 5, 6 and 8. We are getting output logic 1. How many of you able to understand, beta ji? Except 1, 4, 7, 9. It is visible to all of you? Please let me know by writing in the comment section, beta ji. Great. So here we are getting 0. Here we are getting 1 onto the binary of 0, onto the binary of 2, binary of 3, binary of 5, binary of 6. So we have a logical expression possible as this pair, this pair, this pair and this alone. So we are getting, sir, For logical expression for D will become, sir, B bar D bar plus of B bar D bar plus of B bar C plus of CD bar plus of BC bar D. Whether this expression is sufficient to define 8 and 9? Yes. If you observe 9, for 9 we have D is equals to 1. If we have D is equals to 1, then D bar is 0. If we have C is equals to 0, we are getting 0. C 0, we are getting 0. Here B 0, so we are getting 0. So for 9, we are getting 0. However, if you observe 8, B bar D bar itself is sufficient to define 8 because B and D both are low in 8, binary condition of 8. So how many of you able to understand? We need not to take care of that octet. That is not going to form. Is it okay? How many of you now able to understand? Similarly, you can do for E and F as well. E, F and G as well. So what is E? E we are getting high onto the binary condition of 0, onto the binary condition of 2, 0, 2, 6, 8, 0, 2, 6, 8. So for 0, 2, 6, 8, 0, 2, 6 and 8 I am writing because 8 and 9 we will check. So 0, 2, 6. 0, 2, 6. Again B bar D bar and C D bar. So for E logical expression, B bar D bar is sufficient to define 8. C D bar is also defining 9. So we need not to take care of the rest, don't care. Is it okay? That is from binary of 10 to binary of 15. How many of you now able to understand, beta ji? Can you do the same for the F and G as well? Yes, sir. Can you do the same for the F and G as well? Please let me know by writing in the comment section, beta ji. Can you do the same for the F and G as well? Can you do the same for the F and G as well? Let me create for you. So E and F. B bar B, C bar D bar, C bar D, CD, CD bar 0, 1, 2, 3, 4, 5, 6 and 7. So we have E and we have F left out. Now for E, we are getting high onto the binary conditions of. From the truth table, we can observe what are the positions where we are getting output logic high. So onto the binary of 0, onto the binary of 4, 5, 6, 8, 9. So 0, 4, 0, 4, 5, 6, 0, 4, 5, 6, 8, 9, 0, 4, 5, 6, 8, 9, 0, 4, 5, 6, 8 and 9. Same for the F, we can do with the F minimized logical expression for F as well. So we are getting onto the binary of 2, 3 except 0, 1, 7. Except 0, 1, 7. All are high for F. So as per the desired function, now we have the logical expression of each of the component 2, 3, 4, 5, 6. We must have to go with a there are multiple solutions possible. If we opt this, then F will become BC bar plus of CD bar plus of B bar C. So if you observe this again, whether this is sufficient to define 8 or 9 or not, sir, this expression is not sufficient to define 8 and 9. Why? Because sir, for 8, it can't define BC bar. C is 0, so its bar is 1, but B is 0, C is 0, B is 0. So sir, this can't define 8. We must need to add A in the expression. However, in this one, if you observe 0, 4, 5 6 0 4 5 6 8 9. So we have this expression, and we have E is equals to C bar D bar plus of B D bar plus of BC bar. Again, B C bar D bar. It is sufficient to define 8, but can it define 9? No, sir, it can't define 9. So we must need to add A in the expression because it can't define 9. How many of you now able to understand this? BCD. This shortcut method is only true for the BCD. The shortcut method is only true for the binary coded decimal. Why? Because in binary coded decimal, from 10 to 15 we have don't care. So we just need to check 8 and 9, and that will give us information whether that octet is needed or not. And that octet is only needed when 8 and 9 both are high. Is it okay? How many of you now able to understand up to this part? Great, sir. How many of you now able to understand up to this part? Now we have logical expressions. We can easily implement it by using the circuit. Either we can use logic gates or we can use programmable logic gates. Is it okay? So we can implement it to get our desired BCD to 7 segment decoder. How many of you now able to understand this BCD to 7 segment decoder perfectly? Please let me know by writing in the comment section. Sir, E is already complete on previous slide. E is already completed on previous slide. No issue, beta ji. I think I have covered. Okay. Okay, this is not E. Actually, I have made for F and G, na? So this is for G and this is for F. Rest everything is okay. Only the notation I have made incorrect. So basically this is G, F. This is your F and that one is your G. Okay. Please do the correction, beta ji. Because I have chosen from here 0, 4, F, 0, 0, 4, 0, 4, 5, 6, 8, 9. 0, 4, 5, 6, 8, 9. So please do the correction here. This is your F. 0, 4, 5, 6, 8, 9. This is your F basically. I have mistakenly I have done this E. So kindly do the correction. G is okay. This is your G only. For G for G I have considered 2, 3, 4, 5, 6, 8, 9. 2, 3, 4, 5, 6, 8, 9. So 2, 3, 4, 5, 6, 8, 9. Yes, beta ji. Only you have to do the correction of this. Kindly do this G. Okay. So here we have a correction. Just I am mentioning. Please do this correction. Rest everything is okay. How many of you now able to understand? So this is your expression for G and this is your expression for F. Rest everything will remain same. Only F and G notation I have made mistake. So hoping all of you able to understand up to this part. Because of multiple slide changes, something these things will happen. Hoping all of you able to understand this part perfectly. So can you design a binary? Can you design a BCD to 7 segment decoder? Yes, sir. So if you are able to write 1, 2, 3, 4, can you write ABCD as well? Yes, sir. If we have that much of partitions of the segments, we can even display your face as well, sir. How many of you able to understand? In the same way, we can have the entire sentences, sir. Is it okay? Great. In GATE 2009 electronics branch, a question is designed, and it's a common data question. Each question carries basically 2 marks. Okay. So please observe this question. This question is from your BCD to 7 segment display only. 2 products are sold. Please observe the question once. 2 products are sold from a vending machine which has 2 push buttons P1 and P2. When a push button P1 is pressed, the price corresponding to the product the price corresponding to the product is displayed in a 7-segment display. If no buttons are pressed, 0 is displayed, signifying 0 rupees. If no buttons are pressed, 0 is displayed, signifying 0 rupees. If only P1 button is pressed, 2 is displayed, signifies rupees 2. If only P2 is pressed, then 5 is displayed, signifies 5 rupees. So we have P1 and P2 two buttons. If both buttons are not pressed, 0 is displayed. If P1 button is pressed, 2 is displayed. If P2 button is pressed, 5 is displayed. If someone press both the buttons, then error displays, signifies error. So here it is represented like, if no button is pressed, 0, this is the display. If no button is pressed, 0. If P1 is pressed, 2 displayed. If P2 is pressed, 5 displayed. In case if both pressed, E displayed. The names of the segments in the 7th segment and the glow of the display for 0, 2, 5 and E are shown below. Consider push button. First part, consider the names of the segments in the 7-segment display and the glow of the segment for 0, 2, 5 and E are shown below. Consider push button pressed, not pressed in equivalent is equivalent to 1/0. It means if pressed, considered as logic 1. If not pressed, considered as logic 0. Is it okay? In the same way, A segment glowing or not glowing. A segment glows or not glow in the display is equivalent to logic 1 or logic 0. It means whenever the segment, particular segment is logic level 1, then that particular segment glows. Otherwise, logic 0 indicates that particular segment will not glow. So overall, the things mentioned here is the same as we have discussed in the past part. Is it okay? How many of you able to understand? Great, sir. Now please observe the question. And there is very important thing along with this question. So you have to try this question, and I just wanted to let you know that, see, we have one book that is a GATE Wallah electronics, and the same electrical or CS branch also available. So in this book, this is a GATE question 2009. So we have GATE questions. Along with those GATE questions, we have the QR code as well. So if you can just scan this QR code, your favorite sir, Siddharth Sabharwal sir, you will able to see solving this same question. Don't scan right now. First try it by your own and then scan. Is it okay? Then only it will serve its purpose. Is it okay? I can solve it. Already I have told you how to solve it. What you have to do, only you have to construct the truth table now, depending upon the cases given. So we have press button 1, press button 2, and for the press button 1, what is going to display accordingly, those pins are going to be high. Is it okay? So first you have to try, and then to match the answer, you have to scan the QR code. Is it okay? Great. So in the next part of the same question, you have to find the logical expression of A and G for a function P1 in the terms of P1 and P2, then which of the, okay, if the segment A to G are considered as a function of P1, P2, then which of the following is correct? So here you have to observe from the same table, you have to observe which of the following conditions is satisfying. Is it okay? So I am giving you this as a homework to all of you, and the solution is already given in the form of QR. So you can just scan this QR, you will be able to get the solution. Is it okay? Great. So see, if you are learning from YouTube now and you have that kind of book in which a QR code is there and you can just watch the explanation of the questions, then your GATE preparation will be in the next level. Is it okay? Because you know the theory, you know the application. First you will try and then you can just go with the solution. If you are unable to solve correctly, you will watch where you are doing wrong. Is it okay? Great. Now I am moving towards the next topic because already these two questions are available in the video format. So there is no meaning of again going to solve the same. Now please observe encoder. How many of you able to understand Betaji up to this part? Great. So do it in the homework only. Now please come back to the encoder. Next topic is encoder. All of you able to understand decoder? Can you design BCD to access 3 decoder circuit? Can you now design BCD to access 3 decoder circuit? Please tell me, Betaji. Yes, sir. BCD to access 3 code. It's very easy. Input is BCD from binary of 0 to binary of 9, and the output is access 3. So if we have 0, we will get binary of 3, 0, 0, 1, 1. If we are getting the input 0, 0, 0, 1, we will get output 0, 1, 0, 0, binary of 4. So plus 3, access 3 code. Is it okay? So can you design binary to access 3 code converter, binary to access 3 decoder circuit? Yes, sir. So now you can design any desired combinational circuit with the same steps. Come back to the encoder. Primary function of the decoder is to convert binary codes to other codes. So what is the purpose of encoder? Just opposite to that of the decoder. It is used to encode other codes to binary code. Is it okay? Yes, sir. So write down encoder. Encoder. Encoder is used to convert other codes to binary code, such as octal to binary, hexa to binary, and so on. Now please write down, it has maximum 2 to the power n input lines and n output lines. So there is a relation between input lines and output lines. If you observe, if we have 2 to the power n input lines, then we have n output lines. Is it okay? Yes, sir. Next, in binary encoder, only one input line should made high at a time. In binary encoder, in normal binary encoder, only one input line is high at a time. All other inputs are 0 for that time. All other inputs are 0 for that time. Is it okay? Great, sir. Now please observe, Betaji. If we talk about encoder, so how an encoder will work? Please observe how an encoder will work. Let's start with a 4x2 encoder. 4x2 encoder. So if we talk about 4x2 encoder, how a 4x2 encoder will work? Sir, we have total number of inputs 4 and only 2 outputs. So we have total number of inputs 4 and only 2 output lines. Is it okay? Yes, sir. So here I am representing it as I0, I3, I2, I1, I0, and we have Y1, Y0. So this is your 4x2 encoder. Now please observe, Betaji. As per the line, in binary encoder, only one input is high at a time and all other inputs are 0 for that time. So only one input is high at a time. Suppose if I2 is high, then you will get the binary of 2. How many of you able to understand? Yes, sir. So now we know about the input and output and their relationship. If you know about the input, output and their relationship, you can construct truth table. So we have an input as I3, I2, I1, I0 and output as Y1, Y0. Please observe, Betaji, if only one input is high at a time, depending upon which input is high, the corresponding binary is a binary will available at the output of encoder. Is it okay? Yes, sir. So suppose in case if I0 is high, only one input pin is high at a time. All other are 0 at that time. So the binary of 0 get displayed. In case if I1 pin is high, binary of 1 is displayed. Is it okay? Displayed means binary of 1 appear at the output of encoder. In the same way, if I2 pin is high, binary of 2 appear at the output of encoder. If I3 pin is high, binary of 3 is appear at the output of encoder. So from here we can write the logical expression for Y1 and Y0. What is the logical expression for Y1, beta ji? Logical expression for Y1. Where we are getting Y1 high? We are getting Y1 high when either I2 or I3 is high. So any one of them is high. If I1, I2 or I3, any one of them is high, then we will get Y1 high. What is Y0? Y0, we are getting Y0 high when Y0 high when Y0 is high when I1 is high or I3 is high. So I1 or I3, if any one of the pin I1 or I3 is high, I1 or I3 is high, then Y0 will become high. Next is your circuit implementation. If we talk about circuit implementation, then sir, we need two OR gate. Very simple, sir. Decoder contains AND gate, encoder contains OR gate. Decoder contains AND gate, and all of you can see encoder contains AND OR gate. So we have I3 pin, I2 pin, I1 pin, or I0. I0 pin is not connected anywhere. Is it okay? Yes, sir. I3 is connected here as well. So designer need to define the MSB and LSB because then only a user can utilize the circuit. So we have Y1 and Y0. Is it okay? Great, sir. So in case if I3 is high or I2 is high, Y1 will become high. Y0 will become high only when either I1 is high or I3 is high. How many of you able to understand up to this part, beta ji? So this is your basically, sir, 4x2 encoder. How many of you able to understand up to this part, beta ji? Can you please let me know by writing in the comment section? So encoder contains only OR gate. Can I say encoder contains only OR gate? Is it okay? Great, sir. Now let's talk about consider 8x3 encoder shown below with given input, output Y3, Y2, Y1 or Y2, Y1, Y0, Y2, Y1, Y0, Y2, Y1, Y0 will be. So actually we have one encoder this one. So 4 to 7, if any one of them is high, Y2 will become high. And this Y1 is high. Y0 is high. I0, I1, I2, I3, I4, I5, I6, I7. We have 0, 0, 0, 0, 1. So can you tell me, beta ji, this octal to binary encoder will have Y2, Y1, Y0, Y2, Y1, Y0 as 101, 100, 110 or 111. Which of the following is correct? Can you tell me, beta ji? Actually, the purpose of representing this question is to show you a octal to binary encoder logic circuit as well. So hoping all of you can see. Is it okay? And all of you able to understand. In case of 4x2 encoder, we have 2 OR gate. The number of OR gate required, in case if there is no limitation of number of inputs or fan in, the number of OR gates required in encoder is same as the number of output pins. How many of you able to understand, beta ji? Great. So the question, many times one question is asked, how many number of OR gates required to implement 8x3 encoder? So that is equals to 3 only. How many of you able to understand, beta ji? So in this case, I4 pin is connected. I4 pin is connected here. I4 pin is not connected here. I4 pin is not connected here. So this will become 1 and these two will become 0. So we have option number B. How many of you able to understand, beta ji? Great. How many of you able to understand encoder? But actually we are not going to use encoder anyhow. We always prefer to use priority encoder. Now sir, what is the difference between the priority encoder and encoder? See, suppose if you observe your mobile and let us suppose multiple functions will be appear at the same time. You will receive message, you will receive call, you will receive at the same time WhatsApp message, and suppose you are you want to display a YouTube over your mobile. So you have given the input regarding that as well. So what happened? Multiple signals are coming. So now we are getting multiple inputs. Is it okay? So there is one priority, that most highest priority is given to the calls. If you want, you can set messages. Is it okay? So multiple, if in case we want, if we have receiving a multiple input and we want to prioritize the input. Is it okay? I'm hoping now all of you able to understand what is the meaning of priority encoder. So in priority and in normal encoder, only one input is high at a time. In priority encoder, multiple inputs can be high at a time, but the output is only corresponding to the highest priority input. How many of you able to understand this? Great, sir. But the output is always correspond to the highest priority input. So generally, whenever we have to use encoder, we prefer to use priority encoder instead of normal encoder. So let's talk about priority encoder and we will see how to design a priority encoder as well. Is it okay? Yes, sir. So please write down priority encoder. Please write down priority encoder. Priority encoder. So it is a logic circuit that includes the priority function to ensure that when two or more inputs are equals to 1 or high, at the same time, the input having higher priority will take preference. How many of you able to understand? It is a logic circuit that includes the priority. It is a logic circuit that includes the priority function to ensure that when two or more number of inputs are high at the same time, then input having higher priority will have higher preference and will take precedence. Is it okay? Yes, sir. In the priority encoder, MSB bit, normal priority encoder, MSB bit will have highest priority and LSB bit will have least priority. Is it okay? Yes, sir. So as per the bit position, the priority is changing, or priority you can say decreasing. Is it okay? With the increase in bit position, you can say priority increasing. With the decrease in bit position, priority decreases. Is it okay? Yes, sir. Now please observe this one. If more than one input is high at a time, it will still give output for the input having higher priority. Not highest, it is a higher priority. Can you please let me know how many of you are able to understand up to this part? Great. So let's try to design a priority encoder. Okay. Let's try to design a priority encoder. Now please observe, design a 4x2. I am considering 4x2. Design a 4x2 priority encoder. Design a 4x2 priority encoder. Design a 4x2 priority encoder. I am giving some conditions. Assuming the inputs are, let me make it simple. Assuming the inputs are D, assuming the inputs are I3, I2, I1, I0, I0 and outputs are Y2, Y1. Outputs are Y2, Y1. Priority encoder includes one more indicator, that is, or one more output called valid indicator. So please observe once again about the priority encoder. Please see once again here. Suppose if we talk about priority encoder, so a priority encoder, if we have 4x2 priority encoder, then we have 4 input lines and 2 output lines normal, 1 additional output line called valid output indicator. This is what we called valid output indicator. Is it okay? In priority encoder, valid output indicator is also used. Now we have a I3, I2, I1, I0 and we have Y1, Y0. Suppose even if these are high or even if all are high, then binary is always corresponding to the highest priority. Highest priority by default given to the bit position, highest bit position will have the highest priority. Is it okay? So here we have a I3. I3 is a MSB. So MSB will have a higher preference. So you will get 1, 1. In case if this MSB is low, then next highest priority is 2. Is it okay? In case if I2 is also 0, the next highest priority is I1 and similarly goes to I0. Is it okay? Yes, sir. Now come back to the designing of 4x2 priority encoder. So we want to design a 4x2 priority encoder where the inputs are I3, I2, I1, I0. Third output is a valid output indicator. Valid output indicator 1, it means high, indicates inputs are valid output indicator, there is a small typing mistake here. Valid output indicator V is equals to 1 when any input is high. When any input is high. 0 when all inputs are low. Okay? Yes, sir. 1 means output is valid. 1 means output is valid and 0 means output is invalid. Is it okay? Yes, sir. So now we know about the inputs, outputs and their relationship. To design any combinational circuit, first of all, we need to identify the input, outputs and their relationship, that we know. Next is to construct truth table. So please observe, I am giving a representation. We have I3 pin, I2 pin, I1 pin, I0 pin. Output we have Y1, Y0 and want to design a 4x2 priority encoder. So in this encoder, we have one more pin called valid output indicator. Valid output indicator. This valid output indicator indicates whether the observed output at Y1, Y0 is valid or not. Is it okay? So now we know about the input, output and their relationship. Next is to construct truth table. So let's construct truth table. So how to construct truth table? Please observe. We have I3, I2, I1 and I0. Is it okay? Output is Y1 and Y0. But instead of going with all 16 possible combination of I3, I1, I0, I am going only with some. Because in priority encoder, we all know if the higher priority is high, then we will get output corresponding to that particular input pin only. We have one valid output indicator as well. Now please observe, in case if all are 0, then valid output indicator is 0, output is invalid. If the output is invalid, we can just discard the output. It means whatever circuit this particular priority encoder is going to process, that it will not process. Is it okay? If the valid output indicator is low. Is it okay? Yes, sir. Now, in case if we have I0 high, then if all other are low, only I0 is high. If any pin is high, valid output indicator will be high and you will get the binary of 0. In case if I1 pin is high, irrespective of I0, I0 can be 0 or 1. It doesn't matter. If I1 is high, I2, I3 are low, then it doesn't matter what is I0, you will get the binary of 1 only and valid output indicator is high if any of the input is high. In case if I2 is high, then irrespective of I1 and I0 inputs, you will get the binary of 2 valid output indicator high, showing output is valid. Again, if we have I3 high, irrespective of I2, I1, I0, we will get binary of 3 and valid output indicator is high. How many of you able to understand? Now I am able to see all 16 possible combination of I3, I2, I1, I0, all 16 possible combination in just 5 of this. Please observe, beta ji. What is the logical expression for y1? What is the logical expression for y1? Please observe here. What is the logical expression for y1? With the I3 as a MSB, I3 as a MSB and I0 as a LSB, we can say y1 to be high onto the binary condition of. Please observe, onto the binary condition of. If y1 is high, then it means I2 high. I2 high, so high, I2 high, I1 low, I0 low. So this is the binary of 2. Binary of 4. Binary of 4, 5, 6, 7. Is it okay? Yes, sir. Then it is high here, which is possible combination from 8 to 15. So 8, 9, 10, 11, 12, 13, 14 and 15. Is it okay, beta ji? Yes, sir. We can do the minimization of this y1 function as well. So y1 function can be minimized as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have I3 complement, I2 complement, I3 complement, I2, I3, I2, I3, I2 complement, I1 complement, I0 complement, I1 complement, I0, I1, I0, I1, I0 complement. We are getting output high onto the binary condition of 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have two octates, this one and this one, and from these two octates we have, beta ji बताइएगा, y1 will be equals to I3 plus I2. So we have the minimized logical expression for the output y1. We can use the same for finding y0 as well. So what is y0? Y0 we are getting high. Y0 we are getting high with a I3 as a MSB and I0 as a LSB onto the condition of. This is possible 1, 1, 1, 0, 2, 3. 2, 3 and 8 to 15. So 2, 3, 8, 9, 10, 11, 12, 13, 14, 15. We can use K-map 4 cross 4 to find the minimized expression of y0. Yes, sir. So I3, I2, I3, I2 complement, I3, I2, I3, I2 complement, I1, I0 complement, I1 complement, I0, I1, I0, I1, I0 complement. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. We are getting output logic high onto the binary of 2, 3, 8, 9, 10, 11, 12, 13, 14, 15. So we have one octate. Along with this octate, we have one chord as well. How many of you can see this? So y0 logical expression will become I3 plus of, please observe beta ji, I3 plus of, the upper twos will give you I2 complement. I2 complement from here and you will get I1. I2 complement I1. How many of you able to understand beta ji? Great. In the same way, if we talk about a valid output indicator V, then valid output indicator V will have pi of M. Please observe, valid output indicator is high everywhere except the binary of 0. So pi of M 0. Can you write 0, max term of 0 in terms of I3, I2, I1, I? Yes, sir. I3 plus I2 plus I1 plus I0 is the max term of 0 in terms of I3, I2, I1, I0. So we have the logical expression for V as well. Now we have logical expression. Now we have logical expression for all the inputs. We can implement the priority encoder circuit as well. Is it okay? How many of you able to understand beta ji? Please let me know by writing in the comment section. Great. So sir, you are moving very fast. See, these things need to understand. Are you able to understand all the entire combinational part now? Great. You will not found a single question asked in PYQ which is apart from the theory that I have covered in this series so far. Is it okay? Now please observe. For y1 we are getting I3 I2. So for y1 we are getting I3 plus I2. For y1 we are getting I3 plus I2. For y1 we are getting I3 plus I2. And for y0 I3 plus of I2 bar I1. So we need one AND gate. I2 bar I1. I2 bar I1 plus of I3. Is it okay? And we have a valid output indicator as well. So a valid output indicator is I3 plus I2 plus I1 plus I0. So we can use I0, I1 plus I0 plus I3. Anyhow, we have to suffer a logic delay of 2 gate. So I can use like this as well. It's the output, valid output indicator V. How many of you can now see a priority encoder? How many of you can now see a priority encoder? How many of you can now see 4x2 priority encoder? Beta ji, please observe. Let's verify the circuit. Suppose if I3 is high, we don't know about I2, I1, I0, we don't know. If I3 is high, then binary of 3 must be appear. Is it okay? Means outputs are only depends upon the I3. If I3 is high, we have a OR gate. If one input of OR gate is high, we know that output Y1 is going to be high only. If I3 is high, output Y0 is also going to be high only. And since this is high, so this is also going to be high only. We are getting the binary of 3. And the output indicator indicates, valid output indicator indicates output is valid. So we are getting binary of 3. Output does not depends upon I2, I1, I0 in case if I3 is high. Is it okay? Yes, sir. In case if I3 is not high, then suppose I2 is high, then definitely your outputs should depend only on I2. If I2 is high, this will become high because if any one input of OR gate is high, OR gate output is high. And we have I2 high, so its complement is 0. And onto the AND gate, if one input is 0, then AND gate will give 0. 0, 0, so this is definitely 0. Is it okay? The first one is 1, so this is also 1, indicating binary of 2 and valid output indicator is high. So in case if I3 is high, you can observe the output only depends upon I2. It does not depends upon I1 and I0 anyhow. In case if I2 is also low, then your output should only depends upon I1. Please observe. If this is 0, its complement is 1. Is it okay? So if this is 1, we get 1 here and we get 1 here. This is, we are getting 0. Since I1 is 1, so we are getting 1 and this is 1, indicating binary of 1. So you can easily observe that output is now only depends upon I1 in case if I2 and I3 are low. In case if I1 is also low, then that only depends upon I0. How many of you able to understand beta ji? Please let me know by writing in the comment section. This is just to make you understand. So how many of you able to understand a priority encoder as well? So one time question asked in gate, and everything is given. Just you have to identify the logical expression of one of the output of a priority encoder. How many of you now able to understand the entire combinational circuit? Please let me know by writing in the comment section, beta ji. Can I say that all of you are now able to understand your entire combinational circuit? Great. I have given this question to you as a homework. Can you answer this one? Sir, we have here C. So we are getting C bar. So in the output expression, there must be C bar. Is it okay? Yes, sir. And A, B, C, all the inputs are onto the select line. So these are directly representing the min terms. So the min terms we have 0, 1, 2, 6. 0, 1, 2, 6. So 0, 1, 2, 6. Can I put it onto the K map so that we have all the possible minimized expressions as well as intermediate expressions? Yes, sir. So please observe everyone, we have A bar A, because A is given as a MSB, and B bar C bar, B bar C, BC, BC bar, 0, 1, 2, 3, 4, 5, 6 and 7. Where we are getting output logic 1, beta ji? We are getting output logic 1 onto the binary condition of 0, onto the binary condition of 1, onto the binary condition of 2, onto the binary condition of 6. So we have one pair and one pair. Two pairs are possible. And what these two pairs are going to give? Not only these two pairs will be there, but if we consider these two pair, we have A bar B bar plus of B C bar. A bar B bar plus of B C bar. A bar B bar plus of B C bar. But since we are getting C bar, and how you will get C bar? C bar will be possible. C bar will be possible with a chord. So that indicates there is one more chord here. And if we consider this, then what will be the option possible? Because of the C bar is only possible with this chord. So that indicates 0, 4, 2, 6. How many of you able to understand this? Great, sir. So we have 4 as well. Is it okay? So we have C bar plus of A bar B bar, C bar plus of A bar B bar. How many of you able to understand this part perfectly? Great. So in this way, you can easily solve any question based on the multiplexer or demultiplexer. I am giving one more question to you as a homework, and all of you know that we can, how many number of variable functions can be implemented by the multiplexer. It's a MSQ question, so please answer carefully, and you can connect with me on my Telegram, Varun sir PW. So now there is one small question I just want to ask you. We have completed minimization of logical expression, Boolean algebra, Boolean theorems, everything. Also, we have seen K-map and the entire combinational circuit, including adder, subtractor, group adder, parallel adder, ripple carry adder, look ahead carry adder, and then we have completed multiplexer, demultiplexer, decoder, encoder, decoders, by BCD to 7 segment decoders. Are you able to understand up to this part? This is the end of your first part of your digital electronics. Now the next part is sequential. So from sequential, I'm going to start tomorrow. Can you please let me know, all of you able to understand up to the part completed? Great. Hoping you have enjoyed the session so far. So I'm keeping the class, today's class, up to this part only. If you have any doubt, please feel free to connect on my Telegram, Varun sir PW. And also you can connect me on the your official Telegram, electrical gate, electrical and electronics and CS students can connect, and the Telegram details are given in the description of the video. Okay, so you can just go through the description to connect with me. Great. Hoping you have enjoyed the session. Thank you, everyone. Lots of love. And from tomorrow, we are going to start with a new chapter, that is sequential circuit. Thank you, everyone. Lots of love. Good night.